degrees, but we're just going to start off by figuring how do you know what sine, cosine, and tangent of 45 degrees are. The way you know is, first of all, if this is a 45-degree triangle, that's a right triangle, what must this angle up here be, Mr. Murphy? 45. And you also learned that corresponding sides of corresponding angles have corresponding lengths. So therefore, we know that this has to have the same length as that. Are we in agreement? Okay. Now, this is a ratio, so I can pick any number in the sun, put anywhere I want to. Okay? So I'm going to start off by picking one. Once I pick one side, the other one sides are locked in. So what do you want to, what's a nice number for us to pick? 2. You're going to pick 2? That's a little weird, but okay, whatever. I'll put a 2 over here for the hypotenuse. Okay. We do know Pythagoras, do we not? Pythagoras says that x squared plus x squared equals 4. It's the first time Ava's ever picked 2. People try to pick 0, which would be a weird side. 1's really easy. In case this comes up again, which it will soon. Okay, so this becomes 2x squared equals 4. Solve it out for me, Mr. Murphy. Did you say something? All I heard brain fart. Was there something before that? We divide both sides by 2, don't we? Please, please know you how to do that. That's not good. We can't. And then we do what? Okay, I'm getting off that train. Cardio! Square root of 2, and I'm going to go, so you forgot something. Plus or minus. Now, I was mid-sense to making an argument similar to that, but now I'm going to get to make fun of you, because it absolutely can be minus. I'm just not going to explain that right now. But keep that in the back of your mind, that it could be minus. But for right now, I just want it to be a distance, right? So I'm just going to say it's positive root 2. And I'm going to worry about what Mr. Randy said something weird about how it's not going to be. That's square root 2, square root 2, and that's 2, agreed? So if I choose this angle down here, what is my sine of 45 degrees? Well, it would be opposite over hypotenuse, or the square root of 2 over 2. Sine of 45 degrees, square root of 2 over 2. Following the same logic, Miss, I was about to say Rosendo, I was going to physics there. Oh, shoot. Pablo, yes, Pablo. I know Pablo. I know that. I know that. Darn it. Okay, so, Miss Pablo, what's my cosine?
The cosine is addition over hypotenuse.
So in this case it would be?
Square root of 2 over 2.
Square root 2 over 2. So cosine of 45 degrees, root 2 over 2. And then tangent of 45 degrees. Ms. Ramirez? Opposite? Square root 2 over? Square root 2. And square root 2 over square root 2 is? 1. So tangent of 45 degrees is 1. 3 angles banged out just like that. Mr. Pizka, though, what if I want to do 30 degrees? I have to figure out a way to drop a triangle that's 30-degree triangle. How are we going to do that, sir?
I would do 90 degrees, 30 degrees, and whatever the remainder is.
That'd be 60 degrees. But how am I going to know what the sides are for that?
Ratio.
So here's the trick we're going to do. I'm going to do something called an equilateral triangle. What's an equilateral triangle?
All sides are the same.
All sides are the same. So I'm going to make them all x, x, and x. Agreed? All the same. Then I'm going to drop down an altitude. Not an attitude, an altitude. Now when I do that, this was 60 degrees up here, correct? That's 60 degrees, 60 degrees. That's only get same side, all corresponding sides, corresponding angles, right? So that makes this 30 degrees. Makes this 60 degrees, does it not?
Yeah.
All right. It means this side over here is 1/2 x. What is that? Something awful.
It's x squared equals half x squared plus
1/2 x squared plus
b squared
plus the b squared, right?
whatever.
Equals x squared. Agreed? Oh no. Okay. Well, how do I square 1/2? Square top and bottom. So that's 1/4. That becomes 1/4 x squared plus b squared equals x squared. Solve it. Let's go.
Subtract 1/4 x
B squared equals 3/4 x squared. Is that okay with you?
Take the root of it.
Take the square root of both sides. Plus or minus the square root of 3/4 x squared.
Yeah, I would square it. Or I would divide by.
We're going to ignore the minus, even though we're at risk because we know minus is a legit answer. We're going to notice that the square root of 3 is okay. Square root of 4 is just 2. And then square root of x squared is just x. So that would be my third side, square root of 3 over 2x. Agreed? All right, let's do it. We're going to do 60 degrees, right?
Yeah.
So let's start with 60 degrees. Which one do you want to do? We're going to do sine of 60 degrees. Sine of 60 degrees would be what? Opposite over hypotenuse. X's cancel out. Root 3 over 2. Sine of 60 degrees is root 3 over 2. Cosine of 60 degrees is what, sir? Adjacent over hypotenuse. 1/2 x over x, so that would be 1/2. Now again, you're not going to have to derive these from scratch. We're just simply doing it so you have them. Tan of 60 degrees. I need a little more room, so I'm going to lift this thing up.
Root 3 over 2x divided by half x.
So that's going to be root 3 over 2x over 1/2 x. Agreed? X's cancel out. Uh-oh. Fraction divided by a fraction. How do we do with those? What do you say? Skip, flip, and multiply.
Root 3 over 2
Times. Flip. 2 over 1. Those cancel out. Root 3 over 1 is root 3. So tan of 60 degrees is root 3. Bringing it home. I'm going to get my eraser. I'm going to make it a little dot. Now we'll do 30 degrees. Here we go. 30 degrees is up here, right? Are we ready? So 30 degrees is up here. So I want to do sine. Sine of 30 degrees. So that's my opposite. That's my hypotenuse. 1/2 x over x. X's cancel out. I get 1/2 for sine of 30 degrees. Cosine of 30 degrees. Over x. Root 3 over 2. Or negative root 3 over 2. Don't laugh, it's coming. And then tangent, because this is trig, right? Nothing makes sense. Half x over root 3 over 2x. X's cancel out. 1/2 times 2 over root 3. Uh-oh. 2's cancel out. I get 1 over root 3. They can't have a root 3 on the bottom, so what are you going to do? Not squaring it. Squaring changes the answer. Multiply top and bottom by root 3. Root 3 over 3. And that's my tangent of 30 degrees. So basically write those down. We still got 2 sets to do, don't we? We got 0 degrees, then we got 90 degrees. Here we go. Let Mr. Cardiel do this because he's my pro on weird ideas. You ready for pro on weird ideas? All right, so I'm going to go ahead and say my hypotenuse is x, agreed? And I'm going to make this my opposite side here. Agreed? And I'm going to make this my adjacent side. Are we in agreement there? Now, this is, say, 30 degrees or something, correct? Okay. What happens as I lower this side down and lose more and more angle? What's happening here? This stays the same. What's happening to this side? Smaller. What's happening to this side? Getting bigger and longer, right? Agreed? Now, when this gets down to 0 degrees, how tall is this going to be? 0. So the opposite side would be equal to 0. And when this thing slams down on top of this side, what's going to be true about these two sides? I didn't hear what he said. What? Won't these be the same? So that's an x as well. All right. So what is sine of 0 degrees? Well, sine of 0 degrees is opposite, which is 0 over x, which would be 0. So sine of 0 degrees is 0. Didn't do that in geometry. Cosine of 0 degrees. Well, cosine of 0 degrees would be this adjacent over that hypotenuse. X over x, which is 1. Tangent of 0 degrees is opposite over adjacent, which would be 0. I love it. That's the easier of the two weird ones. We're going to do our first bit of trig complete weirdness. Actually, this is our second bit because this is the first bit. What happens when I go the other way, Mr. Cardiel? What happens when I make it bigger, this angle bigger? There's my angle right here, making it bigger. What's going to happen? Just keep going. It's going to be the bottom shrinks to what? When I'm straight up and down, that becomes 0. And this becomes x, becomes the same. Okay? So that's my opposite, that's my adjacent, that's my hypotenuse. Let's do it. Sine of 90 degrees is opposite over a hypotenuse, x over x, which is 1. Cosine of 90 degrees. 0 over x, which would be 0. Now for the one that's going to break our brains. Tangent of 90 degrees. X over 0, which is what? Undefined.